Solar cells, how to turn sunlight into electricity. As the global demand for renewable energy increases, solar energy has become an increasingly important energy option. Whether it is for home use or large-scale power generation, solar cells play a key role in it. This article will briefly introduce the working principle, composition, types, and applications of solar cells to help you better understand this technology and even provide some inspiration for energy use in daily life. 1. The basic working principle of solar cells. Working principle of solar cells is actually very simple. They convert light energy into electricity through a process called photovoltaic effect. When sunlight shines on the surface of solar cells, photons in the light hit silicon atoms in the cell and release electrons. These free electrons flow inside the cell to form an electric current, which is the energy we use to drive various devices. What is the photovoltaic effect? The photovoltaic effect is the core principle of solar cells. When a photon hits a silicon atom in the cell, it releases an electron. This electron is attracted by the electric field and flows to form an electric current. By providing these electrons with wires, they will flow along the wires to form an electric current that we can use. 2. The structure of solar cells. The internal structure of solar cells is the key to converting light energy into electricity. Here are the components of a typical solar cell: positive and negative electrodes. The positive electrode of a solar cell is composed of a metal conductive plate which is used to collect electrons. The negative electrode is composed of a metal grid, which is responsible for outputting electrons. Silicon material. Silicon is the core material of solar cells. It is a semiconductor material that can efficiently convert light energy. Solar cells are usually composed of two different types of silicon: N-type silicon doped with phosphorus and P-type silicon doped with boron. The contact between these two layers of silicon materials forms the p-n junction required for the flow of current. Reflective layer and protective layer. In order to increase the absorption of light, the surface of the solar cell is usually coated with a reflective layer, and a glass protective layer is used to prevent physical damage. 3. Types of solar cells. There are currently 3 main types of solar cells on the market, each with different advantages and disadvantages, suitable for different scenarios. Monocrystalline silicon solar cells, made of a single crystal of silicon. They are more efficient 1519, but the price is also relatively expensive. They are usually dark and suitable for applications that require efficient energy. Polycrystalline silicon solar cells, made of multiple silicon crystals. They usually have a noticeable grainy feel and are slightly less efficient 1317, but the cost is lower, suitable for most homes and small projects. Thin film solar cells. These cells are very thin and often bendable, making them suitable for places like car roofs or backpacks. They have a low efficiency 5.8, but are cheap and suitable for large area applications. 4. How are solar cells connected into a system? The voltage of a single solar cell is low, about 0.5 volts, so multiple cells need to be connected together to meet the voltage and current requirements of daily life. There are 2 ways to connect them. Series connection. When multiple cells are connected end to end, the voltage will accumulate while the current remains unchanged. For example, connecting 60 cells in series can produce a voltage of about 30 volts. Parallel connection. When multiple cells are connected side by side, the current will accumulate while the voltage remains unchanged. This method is suitable for increasing current output. Through a combination of series and parallel connections, solar cell groups can generate the required voltage and current to meet the needs of home and commercial applications. 5. Solar cell efficiency. How to improve power generation capacity. The efficiency of a solar cell is an important criterion for evaluating its performance. It determines how much light energy the cell can convert into electrical energy. Different types of batteries have different efficiencies, and the factors that affect them include light intensity. The stronger the light, the more current the battery produces. Battery temperature. Solar cells lose efficiency at high temperatures, so it is important to ensure that the battery can dissipate heat effectively. Battery surface cleanliness. Dust and dirt reduce light absorption, and regular cleaning of the battery surface helps improve efficiency. 6. Applications of solar cells. The application of solar cells is very wide, covering all areas from home to business to industry. Home applications. Many families install solar panels on their roofs to provide daily electricity and reduce electricity bills. In sunny areas, solar cells can also be used for hot water systems and electric vehicle charging. Commercial and industrial applications. More and more companies are reducing energy costs and achieving sustainable development goals by installing solar cells. Remote areas. For areas without grid supply, solar cells provide an ideal off-grid power solution. They are able to provide basic electricity to residents in remote areas. Solar power plants. Large solar power plants convert solar energy into electricity through tens of thousands of solar panels and supply electricity to residents and businesses through the grid. 7. Future development of solar cells. The future of solar cells is full of potential. As technology continues to advance, new efficient materials and manufacturing processes continue to emerge. For example, new cell technologies such as perovskite solar cells and transparent solar cells are continuously improving the efficiency of solar cells and reducing production costs. As these technologies become more popular, solar energy is expected to become one of the world's main sources of energy.